A large part of the interactive display market is represented by touchscreen displays that enable simple and direct interaction. However, the simple act of touching on-screen targets actually involves complex visual motor coordination of the arm, wrist, hand, and fingers. For people with upper body motor impairments, touch input brings about a variety of accessibility challenges, from raising the arm to landing a finger on the screen to lifting the finger without sliding. For wheelchair users, parts of the screen may not be reachable from the wheelchair, or the pathway to reach the public display with the wheelchair may be little accessible. In this work, we address accessible interaction for wheelchair users and public ambient displays. In a first study, we conduct a systematic literature review and report very few scientific papers on this topic with a preponderant focus on touch input and touchscreens. In a second study, we conduct a systematic video review using YouTube and unveil accessibility challenges for public displays and several input modalities alternative to direct touch. In a third study, we conduct interviews with wheelchair users to understand their experience of interacting with public displays and preferences for more accessible input modalities. Based on the findings from these studies, we discuss two implications: the assisted interaction phase for public ambient displays and the ability dimension for cross-device input to support independent use of public displays via personal mobile devices. We conducted a systematic literature review on the topic of interactive public ambient displays and wheelchair users. After the identification, screening and eligibility stages, we arrived at 20 scientific papers, from which 2 researchers extracted information about display setup, input modality, and accessibility challenges addressed in those papers. We found very little scientific examination of accessibility public displays for wheelchair users. Only a handful of papers describe prototypes of accessible displays, while the large majority briefly mentioned wheelchair users. We found a preponderant focus on touch input, while observations about accessibility challenges were scarce and brief. To find out more, we conducted a second study by running queries on YouTube to identify relevant videos, just like we used queries in our systematic literature review to identify scientific papers about public displays and wheelchair users. This time, we used a larger set of search terms describing motor impairments, health conditions, and types of public displays. After the identification, screening, and eligibility stages, we arrived at a set of 30 videos from which 2 researchers extracted information, just like in the previous study. We identified many mentions of accessibility challenges, which are grouped into 6 categories. The most frequent accessibility challenges were using touch input and reaching to content located too high on the display. We also identified new input modalities such as touch implemented with assistive objects represented by a hand stick, a pen, or objects held with both hands, depending on the specific application and the health condition of the user. Not all of the videos contain dialogue, but when they did, we extracted and analyzed relevant quotes, such as the ones exemplified on this slide, that explicitly mentioned accessibility challenges, possible workarounds, or feelings resulting from the successful or unsuccessful use of interactive displays. To complete our findings, we conducted semi-structured interviews with 11 wheelchair users to understand perceptions about the experience of using interactive public displays and collect their preferences for more accessible input modalities. Most of our participants reported content located too high on the display, difficulty reaching the screen with the hand, and not enough room for the wheelchair in front of the public display as the most important accessibility challenges. We also found that assistance when using a public display that was not accessible was mostly provided by a companion. The highest preferences for input techniques alternative to touch input were for smartphone-based solutions, such as casting the screen of the public display to the smartphone or installing a dedicated smartphone app that would offer the same functionality as the display. We also found statistically significant correlations between participants' preferences for input modalities and their levels of disability and health measured with the HODAS instrument. Participants' comments provided further insights into the experience of interacting with a public display, such as reduced visibility from the wheelchair, perceptions of drawing unwanted attention, and avoiding using public displays because of sanitary concerns. The findings from our studies reveal the importance of providing assistance during interaction with public displays that are little or not accessible. The presence of an assistant means that two people interact with the public display to perform the same task, which depicts a use case not covered by Vogel and Balakrishnan's four-phase model. In such cases, assistance is provided by other people who also become users of the public display. We call this phase assisted interaction and show that it presents unique characteristics which open new research opportunities for public interactive displays. For instance, the secondary user that provides assistance to the primary wheelchair user can participate in the interaction of the public display at various levels of engagement. They can help with a single operation, such as pressing a button located too high to reach comfortably from the wheelchair, which is a one-time assistance. The secondary user can continue from the point where the primary user left off, or can perform the entire task from the beginning during full assistance. These nuances in how assistance is provided have implications for the technical design of public displays that adapt to their users by observing the interaction or that employ user profiles to customize subsequent interactions. Besides interactions with the public display, human-human interactions take place in the assisted interaction phase. The dialogue between the two users needs to be filtered out by displays implementing speech input or tracking users' head or eye gaze, which may get confused by orientations of the user's head not aimed at the display. Finally, there are privacy and security aspects when assistance is sought for interactions that involve confidential or sensible information. Overall, the assisted interaction phase addresses by design those situations where touch input of the public display is little or not accessible to wheelchair users. However, independent use of the display can be accommodated by alternative input modalities to direct touch, among which we found a high preference for smartphone-based solutions. This approach falls in the area of cross-device interaction since it involves a personal device and a public display. This slide shows how smartphone-based input for public displays can be characterized using the taxonomy of cross-device input as a synchronous 1-to-m relationship between one user and multiple devices, fixed dynamics, etc. However, although using smartphones to interact with public displays has been largely addressed in the scientific literature, the resulting interaction techniques have targeted the average user. Moreover, the dimensions of the cross-device input taxonomy do not consider user-specific abilities to employ mobile devices, and thus they offer just a partial view on designing for users not possessing average but specific motor abilities. To complete this design space, we proposed a new dimension of ability to specify motor abilities expected from the user during cross-device interactions involving a mobile device and a public display. For smartphone-based input, this dimension specifies abilities required to operate a smartphone, such as holding the smartphone steadily during operation or touching targets accurately on the smartphone's screen. For this dimension, we suggest using a taxonomy of perceptual motor abilities proposed by Fleischmann in 1967 to describe motor skills in terms of general ability requirements in order to account for human performance on a wide range of tasks with a relatively small number of abilities. For instance, manual dexterity represents the ability to perform well-directed arm-hand movements needed to manipulate the smartphone and hold it steadily for interaction techniques that require pointing the smartphone to the public display. Aiming is the ability to perform accurate tapping on a surface, for example to select targets on the smartphone's touchscreen for technical solutions that involve installing a dedicated smartphone app that offers the same functionality as the public display. For more details regarding our studies and their practical implications for more accessible public interactive ambient displays for wheelchair users, please see our paper. Our findings revealed very few scientific publications on this topic, but we identified a diversity of accessibility challenges and opportunities to implement input modalities alternative to direct touch, which should be examined closely in future work. Thank you for watching.